Hi everyone and welcome to this DCD talk entitled Modular Deployments at the Edge. I'm James Raddings, Digital Portfolio Lead here at DCD, and I'm delighted to be joined by Srikanth Murugan, who's Chief Technology Officer at DXN. How are you doing, Srikanth?
Hi, doing good, James.
Good to be with you. And I suppose to start off, really, are you able to tell us a little bit more about you, about your career journey so far, and what your role at DXN entails?
Yeah, I started in the 2000s or early 1990s, I should say, with the telecom industries. Okay, it just looks like a long back already. So I started with a career with telcos, rolling out GSM mobile base stations and switching networks. Started with India, then joined a US company and started rolling out a lot of these mobile networks in South America, then in a lot of Pacific Islands, Sri Lanka, those kind of countries. So done quite a bit of travel deploying this, and after a while of being more technical and on-site project deployments and project management, decided to take on a different role into pre-sales and solution selling role. And that's when I joined LGC Wireless and was selling GSM solutions mostly to the Pacific Islands and other parts of Malaysia and other countries like that. Finally decided to take a leap out of the telecom industry and then move on to new unfamiliar territory, which was data center industry at the time. In 2012, I moved into a Swedish company called Flex Enclosure that was doing modular prefab data centers, mainly selling into markets like in Africa and South American regions. So joined them as head of pre-sales and started selling these solutions all over the globe. Then in 2019, joined DXN as solutions head and pre-sales lead as well. So head of engineering and R&D for DXN for a couple of years, and then I was promoted into the CTO role with DXN. And so DXN is we do own and operate our own data centers in Australia, and also we sell modular data centers for customers in the US, Asia Pac, so some in South America as well, and but mostly in the Pacific Islands.
Yeah, I must say, out of all these sort of interviews and talks that we've done, you are one of the most well-travelled people that we've spoken to. So,
I have lived almost in every Pacific island. Okay, that's how much I have traveled. Like all the islands, it's probably a dot in the world map, but I've been there.
yeah, because you can get those scratch maps, can't you? I reckon yours must be quite full. So,
It is. It's more than 20 years of travel.
So I suppose, like, from you mentioned about being you sort of promoted into the CTO role, and from in your experience there and from kind of the CTO perspective, what do you think at the moment is kind of the most sort of broken thing in how critical infrastructure is traditionally delivered?
Um, it's an interesting question. Like the critical infrastructures that we are building, like the power, cooling for the data centers and everything, is all extremely engineered and built to last 20 to 30 years, so lifetime. So every customer that comes to and asks us says, I need this data center to last 20 to 30 years. But recently, with all the changes that's happening in the industry, the lifetime of the chipsets and the GPUs is only 2 to 3 years a maximum. They can be 5 years because in 2 years the chipsets gets upgraded. So the lifetime is not more than 5 years. So I feel there is a significant mismatch between the lifetime expectancy of the critical infrastructure of data center versus the lifetime of the CPU and customers' business case based on those 3 to 5 years span. So this is a big imbalance that's happening, and I've seen this from my experience in telco industry as well. When I used to deploy telco networks in the past, the first two GGSM sites used to be built like rock solid rooms, like brick and mortar, and it used to be the most protected room and cool like to the maximum extent. Then slowly people started moving out of it and going to like outdoor cabinets when the 3G started deploying. Now it's more like, oh, it's convention cool, no need of any cooling and no protection, just leave it next to the tower or build it on the tower itself. Like so that kind of transition I feel might happen in the data center industry as well. Right now it's still in the early stages. So it's following the same pattern as the telco industry where people are over engineering the the critical infrastructures for data center, but it will come to a point data centers will have redundancies from one data center to another, so you don't have to do so much of backup and cooling for data centers, and we can start seeing outdoor street side cabinets for data centers and more rugged environments, operational data centers like that.
Yeah, yeah. And in regards to kind of the construction of these things, so DXN completes almost all of its work off-site, and a lot of the industry still sort of assembles on location. So, what kind of made you commit so strongly to that level of prefabricated design?
Yeah, from our experience in rolling out projects, we know most things go wrong when you try to do a lot of work on site. Project work is always messy. Okay, there's a lot of different tradesmen, like hundreds of electricians running around in a typical hyperscale data centers, and there is plumbers and other kind of technicians. So it's a very crowded in a small site in actual data center deployment, and this gets really messy if it's not properly coordinated and things, and you won't, it takes more time and you won't have a quality product because of these kind of things happening on site. And that's why we want to make sure that we are providing a quality product on a timely fashion to customer. So the key three things that why we decided is we don't want to do a project, we want to do a product. So when we're building it in a factory and providing it to a customer, it has become a complete factory finished product. So when customer gets it, there's no compromise in quality because the quality is already checked in a factory and it's been delivered to site. So it's no longer a project, and the customer feels like they are buying, it's like buying an iPhone. So you're just getting a product from the factory. And since we're building it in a factory, it's a very complete controlled environment, and that way everything is in our control. But when you're doing it on site, you have a lot of people that we have to co-work with, like different teams will be doing different kind of job. So your kind of coordination is not in your control, but doing it in the factory keeps it everything in our control. So that helps in delivering the project on time as well. And the last thing is always like less resources. Since it's in a controlled environment, we just need 1/4 of the resources. Say if we need 100 electricians to do this job on site, we only need like probably 25 or 30 electricians will be able to do the job in a factory controlled environment. So it makes sure that we can deliver it, roll out much more coordinated way and much smoother on site when it's finally finished. That's why we try to do as much as possible in our factory, prefabricated and sent to site. So we try to keep it as less as possible on site.
Yeah, and I suppose as well, you can see it works and then add it to something without, whilst protecting uptime, which is the golden word in the industry at the moment. And also, does that play a huge part when it comes to actually scaling something as well?
Yeah.
So just building on the kind of prefabrication approach, how does that adapt to different pressures faced by different parts of the industry? So I'm thinking, we've spoken about data centers, obviously, data centers as a service, perhaps some mining projects that you're involved with as well. Could you tell us a little bit more about how those delivery models adapt?
Sure. Typically, everybody in the big vendors in the market try to sell out of the box solutions. Like, so they want to prepare and create a nice product and then just sell that as a solution, and they want to sell it to all the customers. As I highlighted before, like different industries have different pain points. So when you're trying to target particular market segments, you have to customize the product for that particular industry because you're addressing a different issue for that customer. So that's why one of the reasons why DXN customizes the solution for each industry is for that reason, so that we can address those customers. And similarly, even if it is in the same industry, each customer requirement is quite different. If all my years of experience in selling prefab solution, no two customers are actually bought the same solution. Okay, it's always something unique that customer wants. Okay, even if they're coming from the same mining industry or a degas industry, they will want a level of customization depends on their end client requirements. So you have to be nimble and flexible to adapt to what the end customer requirements. And that's why I was saying we always custom design our solutions and not sell a product. We are not a product seller, we are solution selling. And that's the key delivery model that we take in DXN is we sell solutions. So we start from scratch for every customer.
Yeah, and getting involved with the end customer from the get go and work. Yeah, no, that makes complete sense.
So then that's why we start from scratch. So we don't go with a preset mindset. Okay, this solution or this product fits them. We go find out if we have to go back and design a new product for them. We go back and do that for them.
Yeah. Shifting slightly to workforce, I know that's a huge sort of topic of discussion in the industry right now. From your perspective, how serious is the skills and resource challenge in the industry, really?
It is one of the most challenging issue that we are facing in the industry right now. Okay, the resource constraint is going to be there for a while. It's not going to go away. We are seeing the amount of data centers that is being built and that's being announced each day. There is different people building different massive data centers. And just as an example, a typical hyperscale data center, just on electricians alone, you will need around 800 to 1,000 electricians in just one data center. That's the amount of workforce will be required in building like a 100 megawatt, 500 megawatt, these kind of data centers, the new AI data centers. And it's all time-based because all the customers are rushing on time. They want to be the first to launch and things. So it's all time-based. So they don't want to give you more time to finish it. So they want to pour in as much resources as possible and finish this as quickly as possible. And that's how the market is functioning. So I don't see this subsiding in the near future. For the next at least 5 to 6 years, this is going to be the biggest issue for everyone is the resource constraint, and there's multiple data centers coming up and people need to design the electricians and plumbers. I won't be surprised soon these guys will be the highest paid in the industry. The technicians and the rollout guys, and it's already getting there because of the demand that's happening in the market right now.
Yeah, no. The more I hear things like that, the more I wish I could have made a different choice when I was looking at what I wanted to do with my life. So I should have got a trade behind me instead of studying history. But here we are. When it comes to, I suppose, density of racks getting higher, AI workloads pushing facilities beyond traditional design assumptions, what changes the fastest when you start designing for, sustained high density?
It's quite an interesting question, because if you're doing a hyperscale data centers, when you start the design from scratch and then for deploying it and completing it, it's normally a 2-year cycle from initial start of conceptual design, getting to the detail level where customer signs up on it, and then a 1-year deployment period is typical for hyperscalers, and it's a 2-year life cycle. But by the time these data centers are built, the chipsets are upgraded. Okay, so we are starting with, let's say, for example, GB200 chipset for today, and everything is designed and started the construction. By the time it's completed, the GB300s will release. So everything changes on what was the initial prediction. So that's the biggest problem or assumptions with the traditional design to compare to what we are doing now is we have to be extremely flexible on the designs and keep up with what's coming up in the future for the chipsets, because the power and cooling are still following the chipset. So current rack densities is around 130, 150 kilowatt. The new chipsets that's going to be released by NVIDIA, that's going to be around 600 to 800 kilowatt per rack. So keeping this kind of flexibility is taking the requirements to a whole new level right now.
Yeah, and we're even hearing about the megawatt racks, and some of the racks of today are the data centers of yesteryear. So it's the pace of that is quite frightening. When it comes to kind of looking ahead a little bit and looking on some of the new sort of products and projects that you're working on, I saw that you're working on a new product called StructCore. Could you tell us a little bit more about that and how you see that developing?
Yeah. As I mentioned before, DXN doesn't focus on products. Actually, we focus on solutions. So we were working with a lot of hyperscalers, and DXN always predominantly delivered outdoor modular solutions, and that has been for data centers or cable landing stations or satellite ground stations. These are complete outdoor products. But when we closely working with hyperscalers, and they were looking for something much more indoor product, which will address the main concern when they are working with the construction companies building massive data centers. They want a prefabricated product which fits into the data center and solves the problem where somebody gives the shell of the data center, but where we can do prefab and bring it in and do the same kind of data center that will do it in a module, but into the existing building or the shell of the building. So we then did a lot of work and study with a couple of hyperscalers, made sure we understand the requirements and we come up with this product called Strucco solutions that we have, which is designed to address that key requirement. So we basically want to give them the exact data center that they wanted to build in a brick and mortar, but in a prefabricated way. And so this will have the Stucco hack, will have the entire cable management above the racks, all the bus bar distribution, all the chilled water piping distribution to the racks, everything prefabricated and tested in our factory. So it just goes as one solution, and it can be brought into the site and it can fit out into the entire data hall. So the fit out of the shell then becomes a couple of days instead of like weeks and weeks of job. It can be fitted out and they're ready to roll out. So it's more like a plug and play. So it brings in, it's already tested, it's going to work, just plug and play, like the bring in the racks, connect the power, connect the chilled water piping, and ready to go.
Yeah. And I suppose, how does that enable direct to chip liquid cooling when we're talking about some of those high density racks?
Yeah, it's all this high density piping has to be pre-built in the factory. Okay, the more we do and prefabricate it, that means all the piping is pressure tested in the factory. All the valves and everything is control tested. So everything is, the loop of the whole piping assembly is assembled and tested. So when it comes to site, there is connectors that already exist. So it's like, that's why I said it's plug and play. So all you're doing is connecting the chilled water piping to the hot and cold piping on the top of that. It's just a plug and play kind of so you don't have to redesign it again. You have to keep flexibility in mind for the future. So these pipe sizes are designed for today's sizes or little bit extra, like 130 kilowatt per rack, those kind of densities. So tomorrow 800 kilowatt per rack or 1 megawatt per rack, like you said, comes in, you might need to change this piping to a whole new level. So having this prefabricated and having it as section removable allows you to remove the pipes and put in a new sets of pipes at a later stage. And so from a 4-inch pipe, you can go to 8-inch pipe or even larger if required. So that keeps the flexibility to do that by keeping this in sections.
Yeah, and definitely, I suppose the changing the size of the pipes when it comes to 5 years down the line where two-phase might be a bit more common, it's ready for that. So I saw as well that you're currently delivering a data center for a satellite ground station in Hawaii, and also operating satellite ground stations under a DCAS model in Australia. Could you tell us a little bit more about those, and what do these projects reveal about alternative infrastructure and ownership models?
Yeah. DXN predominantly has done a CapEx model, like where we design, build it, and deliver it to the customers, and the customers will own and operate the facility. And this has been most of the predominant, like Global Star kind of customers, and all the customers. It creates a good one-off revenue for us. It's and reduces our risks of exposure in markets where we don't want to own and operate, like countries, small Pacific islands or tricky countries. We do separate some projects in Africa and things. These are not countries we want to own and operate, but we can supply it to the customers, design it and deliver it, and that's quite good one-off revenue that comes out from that. And this is our biggest revenue that's for DXN. Okay, but recently we have been focusing on as a service model in markets like Australia, and want to do it in APAC in the future as well. But in these markets, we want to own and operate where we design it, build it, and we also own and operate for customer. And this allows customers like maybe American customers to enter into Australian market. Okay, so they can come and focus on their business while we enable them. So where we take care of the operations for them, and this creates a new, nice recurring revenue stream for DXN. Okay, so this increases. It's good for the investors, and they love the DCAS model. It's as a service, and a nice, good recurring revenue for a long term is always good for investors.
Oh, nice. Well, unfortunately, that's all we've got time for today. But thank you very much for taking your time to talk with me. And yeah, it seems like you're involved in some really interesting projects. So yeah, I mean, looking forward to doing this again sometime and staying in touch. But yeah, I mean, thank you very much, and thanks everyone at home for watching.